Welcome to my class. I'm Drew Collop. In today's class, we're going to begin talking about stoichiometry. This is chemical conversions. This can be challenging for some students, so to ease you in, we're going to talk about kitchen conversions, or kitchen chemistry. When baking in the kitchen, in essence, you are doing chemistry. You have to follow a recipe. You mix many different components together, heat them, and you get a new product. There are as many similarities here between the chemistry in the kitchen and the chemistry in the laboratory. So we'll start off with kitchen chemistry. Here we have a recipe to make a cream sauce. You can see we require 1 cup of milk, 2 tablespoons of butter, and 1.5 tablespoons of flour. Notice the short form for tablespoon. I could write that like this: 1 cup of milk plus 2 tablespoons of butter plus 3/2 or 1.5 tablespoons of flour. These are the ingredients we mix together. We'll heat it and we'll get a final product. The final product here will be cream sauce. Here we have a recipe for cream sauce. Let's say this makes a single batch of cream sauce. Perhaps we want to make more or less. We may have to alter this recipe to make a different amount of the final product. What we can do, we can use the recipe to help us convert between the different values. Let me show you. First question, how many tablespoons of butter are required for 7 cups of milk? And I've supplied you with the information that 16 tablespoons is equal to 1 cup. In this example, let's say we have 7.0 cups of milk, and we want to maximize the amount of cream sauce we can make. So the question is how many tablespoons of butter do we need? Well, this is a conversion question. Let's convert from cups of milk to tablespoons of butter. Write down what we're given. 7.0 cups of milk. I want to convert now from cups of milk to tablespoons of butter. Now the question is, how do we find the conversion factor for this? What we do, we go to the recipe. Every time we use 1 cup of milk, we use 2 tablespoons of butter. So these will go in right here. We will then do the math. Cups of milk, cancel out cups of milk. I'm left with tablespoons of butter. Multiply by 2 significant digits, 14 tablespoons of butter. Final answer. So you can see we can look at the recipe, 1 cup of milk, 2 tablespoons of butter, 1.5 tablespoons of flour. These are coefficients in front of the ingredient. We can use these coefficients as conversion factors. Let's try another one. How many cups of milk are required for 2 tablespoons of flour? So I only have 2 tablespoons of flour, so how many cups of milk do I need to add? Write down what we're given. 2 tablespoons of flour. I want to get rid of tablespoons of flour, so I place it on the bottom. I want to convert to cups of milk, so I place that on the top. Again, let's go to our recipe. We're comparing cups of milk again to the amount of flour. 1 cup of milk is 1.5 or 3/2 tablespoons of flour. Cancel out our units. I'm left with cups of milk. Here we get 2.0. I'm dividing by a fraction, so I flip it, I multiply it. 2 times 2 is 4, divided by 3. 4/3 cups of milk. Significant digits. Well, notice, we'll say these are exact quantities. 1 cup of milk requires 1.5 tablespoons of flour. So here I have two significant digits. So I should round this off to two significant digits. This would be 1.33333. So 1.3 cups of milk. Let's try C now. How many cups of butter are needed for 6 tablespoons of flour? Here I have tablespoons of flour and cups of butter. But notice, butter is given in tablespoons. So that's where this comes into play. 16 tablespoons is 1 cup. What's our plan going to be? We're going to go from tablespoons of flour. We will use our recipe to convert to tablespoons of butter. Then we'll use that conversion factor, 16 tablespoons is 1 cup, to give me cups of butter. Write down what you're given. 6.0 tablespoons of flour. I want to go from tablespoons of flour to tablespoons of butter. I will then go from tablespoons of butter to cups of butter. What did we get at conversion factors now? Tablespoons of butter, tablespoons of flour. We have tablespoons of butter, tablespoons of flour. 2 tablespoons butter, 3/2 tablespoons of flour. So 2, 3/2. Cups of butter, tablespoons of butter. We're getting that from here. 16 tablespoons is 1 cup. 16 tablespoons is 1 cup. With units now, tablespoons of flour cancel out tablespoons of flour. Tablespoons of butter cancel out tablespoons of butter. I'm left with cups of butter. Exactly what I asked for. Do the math now. 6.0 times 2, divide by 3/2, divide by 16. This will give me cups of butter. 16 times 2 is 12. 12, we're dividing by a fraction, so we flip and multiply it. Divide by 16 cups of butter. 12 times 2 is 24. Divided by 3 is 8. This is going to be 8/16, which will be 0.5 cups of butter. Significant digits now. Notice we have 2 digits here. These are from the recipe, so they would be exact numbers, and this would be exact as well. 1 cup is 16 tablespoons. So in the end, we actually have 2 significant digits, so I should write this as 0.50 cups of butter. Final answer. So here, we've used the recipe, the coefficients from the recipe, to help us convert from one ingredient to another. Let's look at another example. In this case here, mixing a drink. We're going to make a batch of fruit juice. We're going to take 583 mils of, I'll call this OJ and LJ, of orange juice. We add to that 234 mils of lemon juice. Then we add to that some water. And in the end, we're going to produce, we'll say it, 1 batch of my fruit juice. So here's the recipe. I mix orange juice, lemon juice, and water, and I make up my fruit juice. Now let's solve some of these problems using the recipe here. How much orange juice is required to make 6 batches? Well, here the recipe makes 1 batch. So we'll write 6 batches. If I want to make 6 batches, how much orange juice do I need to buy? I want to get rid of batches of my fruit juice, and I want to convert to milliliters of my orange juice. I go to these coefficients. 1 batch requires 583 mils of orange juice. So 583 mils of orange juice makes one batch. You can see batches cancel out. I'm left with milliliters of orange juice. Multiply those together. Let's say we're making exactly 6 batches. So if it's an exact number, infinite number of digits. So this is an infinite number of digits, and this one has 3 significant digits. So we'll round this off to 3 digits, meaning we require 3,500 milliliters of orange juice. We'll put a line over that 0 to indicate that is significant. So once again, we can use the coefficients in our recipe to help convert between the different ingredients. Let's try B. How much lemon juice is required to make 2 liters of juice? So we're asking how much lemon juice is required to make 2 liters of juice, fruit juice. We'll call it FJ for short. How about that? Now there's a slight problem here. 2 liters of juice. Let's go to my recipe. Notice the recipe gives it by batch, not by the final volume. So what do we have to do? Well, you have to calculate the final volume. Let's convert this over to liters, convert this over to liters. This one is already in liters. We add those up, and we get 2.372 liters. So you can see with this particular question, we had to add up the volumes of all my ingredients to determine what the final volume was of my fruit juice. So 237.2. We take 2 liters of fruit juice. I'm going to convert from liters of fruit juice to milliliters of lemon juice. For my recipe now, we have the volume of fruit juice, and here we have the number of milliliters of lemon juice. So 234 and 2.372. Cancel out units, liters of fruit juice, liters of fruit juice. I'm left with milliliters of lemon juice is what I asked for, how much lemon juice I need. 2 times 234 divided by 2.372, we get significant digits now. Again, let's say this is an exact amount. We're going to make exactly 2 liters. So here we have 3 digits. Here we have 4 digits. So I'm going to round off to 3 digits. This will be approximately equal to 197 milliliters of lemon juice. Let's look at C now. How many batches of juice can be made from 3 liters of orange juice? So remember, to make this recipe up, we need orange juice, we need lemon juice, and we need water. What we'll say is we'll have an excess of lemon juice and water. We have an unlimited supply. But we have a limited supply of my orange juice. We'll call this my limiting ingredient. So it doesn't matter how much lemon juice and how much water I have. Whenever you have a limiting ingredient, it doesn't matter how much of the other ingredients you have, that one ingredient will limit the final amount you can make. How many batches of juice? From 3 liters of orange juice. So I'm going to have 3 liters of my orange juice. I want to convert that over to batches of juice. Let's put in our conversion factors. Now, if we go to our recipe, it gives the amount of orange juice in milliliters. So we'll have to first convert from liters to milliliters. 1 liter is 1,000 mils. Then we'll convert from milliliters of orange juice to batches of our fruit juice. 1 batch from our recipe, 583 mils. Let's cancel out units. Liters cancels liters. Mils cancels mils. Orange juice cancels orange juice. I'm left with batches of fruit juice. So 3 times 1,000 divided by 583. Significant digits now. Exact number, exact number, exact number. Here I have 3 digits. Here I have 2 digits. So I'd round this off to 2 significant digits. 5.1 batches of fruit juice. For this question, if I have an unlimited amount of lemon juice and an unlimited amount of water, we say they are in excess. What we have here is one ingredient that is limited. The orange juice. I only have 3 liters. I called this the limiting ingredient. In chemistry, we call it the limiting reagent. I would like you now to practice. Here's a recipe to make 2.5 cups of buttercream icing. 2 cups of icing sugar, 6 tablespoons of butter, 1.5 teaspoons of vanilla, and 1 tablespoon of milk. So I'd like you to try this out. How many tablespoons of milk? How many cups of icing sugar? How many teaspoons of vanilla? And how much vanilla would you need? Give those a try now, and then I'll take it up. Let's take it up. Let's first start by writing my recipe. 2 cups of icing sugar, I'll call it IS, plus 6.5 tablespoons of butter, plus 1.5 teaspoons of vanilla, I'll just call it V, plus 1 tablespoon of milk. Add those together, and I make 2.5 cups of buttercream icing. I'll call it buttercream icing, vanilla, icing sugar. Just so I don't have to write so much. For this recipe, these coefficients will say their exact values, meaning there's an infinite number of significant digits there. Now, this may not be applicable to the kitchen, but I'm trying to relate this to your chemistry. Hopefully you see where this is going. Question number 1. How many tablespoons of milk are required for 3.5 cups of icing sugar? I'm going to write down what I'm given. 3.5 cups of icing sugar. I want to go from cups of icing sugar to tablespoons of milk. No problem. Cups of icing sugar go on the bottom, and tablespoons of milk go on the top. So that cups of icing sugar will cancel out. It says 2 cups of icing sugar requires 1 teaspoon of milk. We'll do the math now. 3.5 times 1 divided by 2 is going to be 1.75. Units, cups of icing sugar, both cancel out. I'm left with tablespoons of milk. Significant digits now. What did I say? I said the coefficients in our recipe are exact. So here I have 2 digits, so I will round this off to 2 significant digits. 1.8 tablespoons of milk. Final answer. Let's try the next one. How many cups of icing sugar would be required to make 6 cups of icing? So I want to go from cups of icing to icing sugar. Cups of buttercream icing to cups of icing sugar. Let's just replace this with buttercream icing to make sure we're not getting confused. Conversion factor now, going from cups of buttercream icing to cups of icing sugar. Go to our recipe, 2 cups of icing sugar, 2.5 cups of buttercream icing. 2.5. Units, cancel out. 6 times 2 divided by 2.5. 4.8 cups of icing sugar. Significant digits now. I said these were exact, so I'm going to round this off to 5 cups of icing sugar. Next up, how many teaspoons of vanilla are needed to use 8.25 tablespoons of milk? 8.25 tablespoons of milk. Let's say that's all the milk I have. I want to use it all up. So I got to know how much of the other ingredients to mix with that limited ingredient of milk. Tablespoons of milk, teaspoons of vanilla. Tablespoons of milk, teaspoons of vanilla. 1.5 teaspoons vanilla to 1 tablespoon milk. Tablespoons of milk goes on the bottom. Teaspoons of vanilla on the top. 1.5 teaspoons of vanilla will be used every time we use 1 tablespoon of milk. Tablespoons of milk cancel out. 8.25 times 1.5. Significant digits now. Remember I said everything from our recipe was exact numbers. I have 3 digits here. Going to round that off to 3 digits. That's a 7, so it rounds up. This is approximately equal to 12.4. Lastly now, I want to make 8.5 cups of buttercream icing. How much vanilla do I need? 8.5 cups of buttercream icing. Conversion factor, we have cups of buttercream icing on the bottom, and vanilla was given by teaspoons of vanilla. Go to our recipe now. 2.5 cups buttercream icing, 1.5 teaspoons of vanilla. We use those coefficients to convert between those two ingredients. Buttercream icing cancels out, leaving me with vanilla. 8.5 times 1.5 divided by 2.5, giving me 5.1 teaspoons of vanilla. Again, those are exact numbers, 2 digits, so this is already in the proper number of significant digits. Final answer. Here we have a recipe. We mix ingredients together, it goes through some sort of process, and it makes a final product. In order to properly make the final product, a certain amount of each ingredient is required. We have a coefficient that comes in front that tells us the exact amount of that ingredient that is required. If we know these coefficients that come before the ingredient, we can use that to switch between the different ingredients. We've selected this as a way to ease you into stoichiometry. I'm hoping that each of you has baked something in the kitchen and followed the recipe. In the laboratory, we don't call it a recipe. We call it a protocol. We don't call them ingredients. We call them reactants. We do call it a final product. And those coefficients, well, we call them coefficients. And part of the reason why I made them exact values is because with a chemical equation, that is true. Those numbers are exact values, meaning they're not involved in calculating significant digits. Before we end this lecture, I want to introduce one concept. If you have a dozen eggs, how many eggs do you have? Hopefully you've heard the term dozen. 1 dozen means you have 12 objects. It's a short form. So if I have 1 dozen eggs, I have 12 eggs. If I want a dozen donuts, I get 12 donuts. Because those two things are equal, I can convert between objects and dozen. Let me show you. How many eggs are in 16 dozen? Write down what I'm given. 16 dozen. I want to convert between dozen and eggs. Well, 1 dozen is 12 objects. An egg is an object. Dozens cancel out. 16 times 12 is 192 eggs. Significant digits now. We're talking about eggs. If you have half an egg, you don't have an egg. So when we round off these values, we go to the nearest whole number. 192 eggs is 16 dozen. So once again, anytime you have two things that are equal, we can use that equivalency as a conversion factor. We can go the other direction. how many dozens are in 594 apples? Write down what we're given. 594 apples. Convert this between, I want to get rid of apples. I want to convert to, how many dozen of those do I have? Well, 1 dozen is 12 of anything. You can see apples cancel out. And I'm left with 594 divided by 12. I'm left with 49.5 dozen. Because all these values are exact, we'll leave it as 49.5. Once again, if you have half an apple, you don't have a whole apple. Now you might wonder why I'm focusing on the term dozen so much. I'm trying to ease you into the next concept. So we said that the word dozen means 12 objects. Let's talk about a new concept, the concept of the mole. If you have a mole of eggs, how many do you have? Well, mole is similar to dozen. 1 mole just represents 6.022 times 10 to the 23 objects. So, if I have a mole of eggs, how many eggs do I have? Well, I have 6.022 times 10 to the 23 eggs. Please commit that number to memory. 6.022 times 10 to the 23. Be careful. Oftentimes students have difficulty with those final numbers. Notice one is 22, one is 23. They are not the same. This is a common mistake students make. 6.022 times 10 to the 23. This is a special number. It has a name. It's called Avogadro's number. In the laboratory, we don't count atoms. That's not physically possible just yet. Instead, we weigh that. We have to relate the weight of a chemical to the number of atoms or molecules in that chemical. We use the term mole to signify that. And in our next lecture, we'll expand on that. So from this lecture, try and remember that things in everyday life relate to things in the lab. If you've ever made a recipe, you know you mix ingredients together in a certain amount, and they make a certain product. And if you have a limited amount of one ingredient, you can only make a certain amount of that final product. In addition, sometimes we use short forms for a large number of objects. Instead of saying 12 donuts, we say 1 dozen donuts. Well, if I wanted a mole of donuts, that would be 6.022 times 10 to the 23 donuts. Just like the dozen relates to a certain number of objects, the mole also relates to a certain number of objects, however, a much larger number of objects. We'll discuss that more in the following lectures. Again, please commit Avogadro's number to memory. That's all for today. Until next time.